Hello everyone. So today we are going to see joins. So joins are used to retrieve data from the multiple tables at a time. So in a relational database, we are storing related data in the multiple tables like employee details and department details. Second example is customer details and order details. So employee details will be in the employee table, and suppose department's details in the department table, customer details in the another table, and order details in the another table, etc. So to combine data and retrieve data from them, we need to use what? Joins. So joins are again classified into two ways. So first one is non-ANSI joins, format joins. This is introduced in Oracle 8i, and ANSI format joins. This is introduced in Oracle 9 version. So we'll further see what is the difference between these two joins. So when we retrieve data from the multiple tables on the basis of where clause, then it is called as non-ANSI format join. And when we retrieve data from the multiple tables with on clause condition, then we called as ANSI format join. So this is a difference. So when we retrieve data from multiple tables on the base on where clause, then it is called as non-ANSI format joins, whereas if we use the on clause, then that joins are called as ANSI format joins. So syntax, you can see that select star from table, table name 1, table name 2, where join condition. So here you can see where clause, while in the ANSI join syntax we use the what? On clause. So let us see first one, that is equijoins. So in this in the non-ANSI we have three types, that is equijoin, non-equijoin, self-join. So we'll see examples of all three. And also in the ANSI format joins we have inner join, outer join, left outer join, right outer join, full outer join, cross join, or we can see Cartesian join, and natural join, and we will see the example of all these. So let us go and see first one is equijoin. So in equijoin, retrieve data from the multiple tables on the basis of this equal operator, that is called as equijoin. So when we use equijoin between two or more tables, so what is the condition for the using this equijoin? That is here. So when we use the equijoin between two or more than two tables, there must be common column or common field name is. That means if you want to use this equijoin on that two table whatever we are using, that two table must have one common column, and that common column name may be similar or not similar, but it is recommended to take that name as a similar. So you'll understand by one of the example. So before that we'll see this theory. So common column or common field data type must be matched. So whatever the common column between that two table is there, that column data type must be matched. So when we perform any join operation between tables, there is no need to have a relationship, that is primary key and foreign key relationship, that no need to require when we perform any join operation. So equijoin always retrieving only matching data or matching rows. So let us see one of the example. So here I am using SQL plus. So here I have already created the tables, that is select star from course and select star from student. So these are the tables I have created, and in these tables you can see that there is a common column, that is CID. So first condition is while using the joins we should have the common column, and the name of that common column can be equal or different, but it is recommended to take the name as same, and their data type should be same. So let us see if I write here DESC COURSE course So here we can see CID column name and its data type. And if I describe this student table, so here we can see the common column is what? CID, and it's the data type. Here you can see in the course this data type, and in this student table the data type is same. So this is a must while using these joins. So again I will execute this, select star from student and course. So this is the common column CID, that means we can use here a join. So let us see what is the example. So write a query to retrieve student and corresponding course details from the student course table by using the Equijoin. So here what you have to do, you have to retrieve student and corresponding course details. So let us, so here we have to retrieve student and their corresponding course detail. So if we see there, Sai course ID is 10, that means he taken this C course. John is 20, that means he is taken Java course. 30 is not available. 40 means Oracle course. 50 is there or not? No. 45, so he is taken the Spring. So how can we retrieve? So I will write a query, select star from first table is student, comma course. So I will give here alias name for student ES and course C, where, as this is a where what we have to do, we have to compare this course ID. So where S dot CID equals to C dot CID. So here we can see student and their corresponding courses are coming. So here we use the Equijoin, and in that we use this where clause, and here we are using equal. That's why this is called as Equijoin. And we can see that student and their corresponding courses are coming here. So this is a way we can use Equijoin. So this is the first one in non-ANSI format. So in the non-ANSI format we can see that we use the where clause, right? So let us see next example on this Equijoin. So what is the rule of join? A row in a first table is comparing the given join condition with all the second table. So while joining, this is a rule. So what happened? We are using this select star from student as course C, where student course ID equal to this course ID. So what will happen? This internally, this first one is checked with all these rows. So it will check size CID is 10. It will check with this first one. Then it is matching. Then it will print this. Next one is, it will check with 20. It is not matching. 40, 45, 60. So all these are not matching. It will leave that. Next it will come to second one. So it will see 20. So 20 is first one is matching, no. Second one is matching, yes. Then this course ID, this course detail and student details will be printed. Then again it will check further 40, 45, as these are not matching. So it will leave that. Then next it will go to third, and it will again check all this one. Then it will go to fourth. Then again it will check for all these course rows. Fifth, sixth. So as it will check this first row with all this, and matching data it will print. So here we can see student and its corresponding course are coming. So this is a rule of the join. A row in the first table is comparing the given join condition with all the rows of second table. So next example, let us see. Write a query to retrieve student and course detail from the table if the course ID is 20. So let us see how can we write the query for this? So here we have to write a query only for what? If the CID is, that is course ID is 20. So let us see how can we do that. Uh, as we have seen above, this is the same, but further we have to add only one condition, and student.cid equals to 20. So here you can see only the course ID 20, that corresponding course and student are coming. So this is a way we can write query for this question. Write a query to retrieve student and course detail from table if CID is 20. Now next one, in this we will see inner join. So let us see what is inner join. So inner join is similar to Equijoin, retrieving data from multiple tables with on clause. So let us see the example. Write a query to, so as above we seen this example, we will see how can we write a query by using this inner join. So let me clear the screen. First one table is, we have student and course. So here we have to use the inner join, and we have to retrieve data from these two tables on the basis of this CID. So student and their corresponding course, we have to retrieve data. So let us see by using inner join how can we do that. So select star from student, its alias name I will take as yes, and here we have to use the inner join. So inner join, and next table name you have to use course, its alias name I will take C, and here make sure that we have to use on clause, on yes dot cid equals to c dot cid. So here we go. Here you can see it is similar to Equijoin. The data, whatever output we are getting while using the Equijoin and this inner join, this is same, but only the difference is syntax is different. In the Equijoin, what we are doing, we are not using this inner join, and we are using this here where clause. But in the inner join, what you have to do, in this both two tables in between, we have to use this inner join, and also the clause will be on. So this is the major difference, the clause and this inner join, and all the things are same. So this is a way we can use inner join. So let us see why ANSI joins, why there is a difference between this non-ANSI and ANSI. As this you can see, we have seen the non-ANSI and ANSI both are doing, that is giving the same result. So why this is we are using this both. So let us see what. So these joins are introduced in Oracle 9i version. The main advantage of ANSI joins are portability. So it means that we can move join statement from one database to another database without making any changes, as it is the join statements are executed in other database. So why Oracle introduced this ANSI joins? Because of the portability. So what is the problem with the non-ANSI joins? That is, we can't that are not portable. That it means that can't be we move on the other database, but these ANSI joins are portable. It means that we can move the join statement from one database to another database. So that is why Oracle introduced this ANSI joins. So next one we'll see outer join. So outer joins is coming in what? These ANSI joins. So let us see. So in the above Equijoin or inner join, we are retrieving only matching rows, but not unmatching rows from the multiple table. So to overcome that problem, then we use outer join mechanism. And there are three types in the outer join. First one is left outer join, right outer join, and full outer join. So let us see first one, that is left outer join. Retrieving all the rows matching and unmatching from the left side of the table, but retrieving matching rows from the right side of the table. So let us see the example of left outer join. So select star from course, select star from student. So in the inner join we are retrying only the matching data. So to overcome this, that is, if you want to retrieve unmatching data also, so there comes a outer join, and in outer join we have three types, that is left outer join, right outer join and full outer join. So let us see left outer join. So in the left outer join what will happen? So in the left outer join, unmatching and matching data from the left, that is, if I take the left table as student and right table at course, so all the unmatching data from the left, matching and also unmatching data from the this left table will become, and only matching data from this course table will become. So let us see the example, then you will understand this. So let us write the query. So select star from, I will take student as a left table, so alias name I will take as, then we have to write what, let me maximize this, also font size, yes. Now left outer join, next table is course C, and here what clause we have to use, on s dot cid equals to c dot cid. Let's execute this, and here we go. So in the left outer join, all the matching and unmatching rows will come from the left table, and all the matching rows from the right table. So here we can see all the rows from the student table are coming here. So in the student we can 1 to 6, so 1 to 6 is coming, but only the matching CID from the right table we can see, from the course table only these 4 rows coming, because this matching data is there, 10 10 20 20 course ID 40 40 40. So as we have seen, in the left outer join, retrying all rows matching and unmatching from the left side, but retrying matching rows from the right side table. So this is a way you can use left outer join. So this is this query is in the ANSI format. So in the non-ANSI format, how can we write this query? So this is same, but on this left outer join we have to not use in the non-ANSI format. Here we have to use the comma between these two tables, and at this we have to use the where clause, and we have to write the plus on the right side. So here you can see we are getting the same data. This is a non-ANSI format query, and this is a what, ANSI format query. So this plus means here we have to do the, on the right hand side we have to do the filtering operation. That means only the matching data should come from the right side. So this is the way we can write this non-ANSI format for the left outer join, and this is for the ANSI format. Next one is right outer join. So it is opposite of left outer join. So retrying all the rows matching and unmatching from the right side, but retrying matching rows from the left side. So let us see the example. So as we have seen, let me take here course table and student table, and now we have to perform right outer join. So in this query we have to modify only this right, on the place of left we have to write right. So here we can see all the matching and unmatching data from the right table is coming, and only matching data from the left table is coming here. So right, on the right we have course, so all matching and unmatching will come here, and on the left the student, only matching data will come here. So this is in a ANSI format, but how can we write in the non-ANSI format for this right outer join? Let us see. So as we have discussed, so we have to do filter operation on the left side. So in this we have to add plus. So If I do enter, so here you can see this is a non-ANSI format query and this is ANSI format. I hope you are understood this. Now next one is full outer join. So retrying matching and also unmatching rows from the both the side of table. So unmatching and matching from the both side. So in the left we are only retrying matching and unmatching from only left side. In the outer right outer join we are only retrying matching and unmatching from right table. So if you want to retry from both the tables, that is matching and unmatching rows, then we have to use the full outer join. So let us see how can we use this. So student table is there, course table is there. Now what we have to do here, we have to replace left with the full. So full outer join. So here we can see all the rows are coming, that is unmatching and matching from the both the tables. So this is a matching, this is a matching 2020, but 30 is not there in this. So at this place we will get null. So 40 is matching, its corresponding is coming. So 50 there is no corresponding to this, so here coming null. 45 matching, and 60 there is no corresponding to 60 in the student, so here it will come null. So this is our full outer join, retrying matching and also unmatching rows from the both side of table. So this is a ANSI format query, but how can we write a non-ANSI format query? So you might be thinking we have to write here plus, but it will give us a error. Here we can see we are getting the error. So by using this we can't write this non-ANSI query for this our full outer join by using this plus. So there is a special one we have to use, that is union operator. So first one I will write this. This is for what? Right outer join, and I will use here union operator, union, and here I will write query for non-ANSI format query for the left outer join. So all this result of this right outer join union left outer join, this will give us a full outer join. So if I execute this, so here you can see this is a result and this result is same, only the difference is this is in the ANSI format and this is in the non-ANSI format. So this is about full outer join. So next one is non-Equijoin. So what is non-Equijoin? Retrieving the data from the multiple tables based on the any condition except the equal operator condition is called as non-Equijoin. So except the equal operator condition, if you use the other condition, then it is considered as a non-Equijoin. So in this join we can use the following operator such as less than, equal to, smaller than equal to, and between. So let us see one of the example on this. Let me clear the screen. Here I have already created one table called test 77. I think select star from test 77 and test 88. So here we have to apply non-Equijoin on these two tables. This is having the common column, that is serial number. So let us see, select star from test 77 comma test 88, where I will take alias name of this t1 comma test 88 t2, where t1 dot SNO is greater than t2 dot SNO. So what do you think, what we should get the result? So here these are the two tables having the common column SNO, and we are using this condition, that is t1 dot SNO should be greater than t2 dot SNO. So what we have seen, This first one will check with all the rows. So it will check 10 is greater than 10, no. 10 is greater than 30, no. So there will be no row corresponding to this. Next it will check for this 20. So 20 will be checked with the 10. Is 20 is greater than 10? Yes. Then we'll get 20 Adam and 30 1 5 000. This row will come. Next 20, yes, this is done. So only no, at this place 10 will come, as we are checking the first row. So this will be the combination from here to here. Now it will check with this 30. Is 20 is greater than 30? No. So only this will come. So let us execute this, and here we go. 20 Adam and 10 25,000. This is coming, and we are not using here equal operator, so that's why it is a non-equivalent join. So next one is cross or Cartesian join. So joining at two or more than two tables without any condition is called as cross or Cartesian join. So in a cross join, each row of the first table will join with each row of second table. That means a first table is having m number of rows and second table is having n number of rows. Then the result will contain m into n number of rows. So in the ANSI format we can write query like this, and in the non-ANSI we can write query like this. So let us see example. So let me clear the screen. So first table is, we'll take at student course. So here 6 rows are there, here 5 rows are there. So if you apply cross join, the number of rows will be 6 into 5, that is 30. So select star from student cross join course. So here we can see 30 rows will come. Now this is in ANSI format. If we write in non-ANSI, here we have to give cut this cross join and comma we have to give. So here we can see the same result will come here, that is 30 rows. So this is in ANSI format, this is in non-ANSI. So what is the application for this using this cross join? Let us see. So the application of cross join, so let us suppose we have two tables, that is item 1 and item 2. In the item 1 we have pizza, burger and its price, and next one we have Coca-Cola and Pepsi and its price. So if I want to find the total price by this each, that means for pizza with Coca-Cola and for pizza with Pepsi, for burger with Coca-Cola and for burger with Pepsi, then in that case we can use the cross join. How can we? So if I write a query, select i1.iname. i1 is alias name for this first table, i2 is alias name for this second table. So i1.iname, i1.price and i2.iname, i2.price, and their price I will combine, and next that column name we can take as total. So what will be the result? So pizza, Coca-Cola, so their price will be 275. Pizza with Pepsi, their price will be 278. Burger with Coca-Cola, their price, and burger with Pepsi and their price. So this is one application for this cross join. So next one is natural join. So natural join is similar to Equijoin. When we use natural join, we should have a common column name. This column data type must be same. So whenever we are using natural join, there is no need to write a joining condition by explicitly, because internally Oracle server is preparing a join condition based on the equal operator with the column names automatically. So by using the natural join, we avoid the duplicates column while retrieving the data from the multiple tables. So let us see how can we use this natural join. So we have two tables, that is course and student, and here we will apply natural join. So select star from student natural join course, and here we go. So in the natural join, the matching, that is course ID, is coming. So student and its corresponding course name, student corresponding course name, and here you can see that the duplicates columns are not there. So let us see again what is this natural join. Natural join is similar to Equijoin. So what we are doing in Equijoin, let us write a query. So if I write in Equijoin, what we are doing, student yes comma course C, where yes.cid equals to c.cid. So here you can see the result of this and this is same, only the difference is this duplicate column is not there in this, and we have not written any condition here. So in the natural join, what will happen, whenever we are using the natural join, there is no need to write a joining condition by explicitly, because internally Oracle server is preparing. So internally Oracle server will be prepare joining condition on based on equal operator with the column names automatically. So this is the advantage of using natural join. We need not to write this equal, it will be internally taken by Oracle. And make sure that while applying this, the common column, that is this common column, its data type must be same and name must be same. So this is the use of this natural join. Now last one is self join. So joining a table by itself is called as self join. In a self join, a row in a one table is joined with the row of the same table. So when we use the self join mechanism, then we should create an alias name on a table. So once we create a alias name on table, internally Oracle server is creating a virtual table or copy on each alias name. So when we create a number of alias name on a single table, by each alias name should be different. So the whatever alias name we are creating, that name of the alias name should be different. So self join can be implemented at two situations. First one is comparing a single column values by itself in the table, and next one is for comparing a two different column values to each other in a table. So let us see the example of self join. So in the self join, the table is comparing with itself. So joining a table by itself is called self join. In a self join, a row in the one table join with the row of same table. So let's suppose what we can take as example of this self join. I have one table called select star from EMP, and this EMP, these are the rows, and here what you have to do, write a query for retrieving the EMP info which is having same salary as that of EMP Scott. So in this employee table, we have to write a query to find the employee which is having same salary as that of employee Scott. So Scott is having a salary 4070. So what are the other employees which is having the same salary as that of Scott? So if we check here, so Ford is another employee which is having the same salary as Scott. So here how can we use this self join? So let us see. Select I will take E1 as alias name of EMP. So E1 dot employee name comma E2 dot salary, E2 dot employee name, E2 dot salary from EMP E1 comma EMP E2, where E2 dot ename equals to Scott and E1 dot salary equals to E2 dot salary. And here we go, we are getting the result Scott and Ford. So what is the question? Write a query for retrieving the employee information which is having the same salary as that of employee Scott. So in this we have to find the employee which is having the same salary as that of Scott. That means we have to compare this table row with this employee table row information with the employee table rows. That means it is a self join. So as we have discussed, in this, joining a table by itself is called as self join. In the self join, a row of one table join with the row of same table. So row of this one table is joining with the row of same table. So what we are use, this alias name we have created E1 and E2. So what will happen? Oracle will create one copy of this, all these two. So for the E1, the employee table will be there, employee table data will be there, and E2 EMP table data will be there. So as we have given the condition, we have to write a query to get the employees which is having this has salary as that of Scott. So I have taken these two tables. These two tables are the same, but I have given here alias name E1 and E2, and in this I have given the condition the name should be equal to Scott and the salary of that should be same. So we will get the result Scott's salary should equal to Ford. So this is an example of self join. So self join is very important. So in which condition self join is implemented? Comparing a single column value by itself in the table and comparing two different column values to each other in a table. So when we use this self join mechanism, then we should create an alias name on a table. So these are the joins and their example we have seen. So these are the two format mainly we have, that is this non-ANSI and ANSI. So ANSI are portable across the different database, but these non-ANSI are not portable. So we have seen in the non-ANSI Equijoin, non-Equijoin, self-join, and in the ANSI format join we have seen inner join, outer join, left outer join, right outer join, full outer join, cross join, or we can say Cartesian join and natural join. So these are the joins. So if you like this video, you can hit the like button and subscribe to our channel.